All right, this is section 8.4 of area. We're going to do area of regular polygons. First term that I want to define is a circumscribed circle. Okay, this is going to be a circle that contains the vertices of a polygon. Okay, so right here, if you look at this triangle, all three vertices are contained on the circle. So therefore, that's a circumscribed circle. This here looks more like a regular polygon, or more in particular, a regular pentagon. Oopsie. And so again, all the vertices are on the circle. And that's what a circumscribed circle is. Okay. There's going to be a radius that exists in a regular polygon. And some people are probably thinking, no, a radius only consists in a circle. Correct. If you think about the circumscribed circle, okay, about a polygon, all of these red segments, those are all radii. Why? Because it goes from the center of the circle to a point on the circle. So that's a radius, that's a radius. Okay, these are all radii that we are going to be using in the polygons to find the area sometimes. Okay, so this is a radius of a regular polygon, and they only exist in regular polygons because, well, they could exist in other ones, but we're going to mainly focus on those because we're doing area of regular polygons. There's another term called an apothem or apothem, however you want to say it. This is going to be only of regular polygons. Here's a definition. It's the distance between the center and then the side of the polygon, okay? And that's the perpendicular distance that is, okay? So there's the center of the polygon, that green segment. It's obviously going to be perpendicular. So that distance right there is what we call an apothem, okay, or apothem. And it can go anywhere on the figure. So this one here is about there. There's your right angle. So that distance right there is called an apothem. Okay, the reason we need to know that is because it's going to be in your area formula. So what is this area formula for a regular polygon? So here's your conjecture. The area of a regular polygon is given by the formula A equals 1/2 times little a times s times n, or A equals 1/2 apothem times perimeter. This one's a little bit shorter, so we are going to probably use that one mostly. However, it's the same thing. If you focus on just that part right there, S times N, S is represented by the length of each side, and then N is the number of sides. N is the number of sides. So whenever you take the length of one side and you multiply it by the number of sides, that's going to get you perimeter right there. And so that's what capital P stands for over here. So little a stands for apothem. S represents the length of each side. N is the number of sides. Okay, and capital P is the perimeter. So how do you see that on the actual polygons? I drew two of them here. So here's a regular hexagon. This would be the length of the side, and that's the apothem. That's the apothem, and there's the length of the side. So it's pretty simple. It can be in any regular polygon. Okay, that's all there is to it. Now we just want to see them as examples because some of these examples can be pretty challenging. So here and all of these are going to be regular polygons, okay? So this is a square. That's a regular quadrilateral. And so when you think of the square, you actually can use two formulas because you're probably thinking in your head right now, well, area of a square is just base times height, or more in particular, it's just side times side, which is side squared. Okay? So whatever the length of this side is, you just times it by itself, or some people consider this the base to height. So you could actually use that formula if you want to, okay? The actual apothem, goes from here to here. And this, again, is your radius, because a circle can be circumscribed about this circle. So that's your radius, which is 5. So you don't want to plug this 5 into any of the formula. So your other formula that we just learned was 1/2 apothem times perimeter, okay? Once we figure out the apothem, the unique thing about this and the square is that the apothem is exactly half of the side. So that's something to think about. So the apothem is half of the side. So once we find the apothem, well, then you should know the entire side. Okay, so you have to remember a little bit about your special right triangles. Remember this right here bisects the angle right here, which is 90. So you should know that this is a 45, 45, 90 triangle. Okay, and so when you remember that, there's 2 ways you can solve for the apothem. Okay, because that's what we want to solve for. Well, I guess you can solve for this side, but remember this side is the same as this, so it doesn't really matter which one you solve for because it's exactly the same. So I have a great memory of what to do if this is a simple whole number to get the apothem. Okay, you just take half of this and times it by 2. So this is technically 5/2 radical 2. Okay, now if you don't remember that, that's okay. You're going to have to use trigonometry to figure out the length of this, and your answer will just be in decimal. So we're going to do sine of 45 degrees equals opposite over hypotenuse, okay, little a over 5. And that'll get you your answer in decimal, okay? The other way to write this over here, half of 5 is 2.5. So if you were thinking 2.5 radical 2, that's the same thing. Okay, so since this is 2.5 radical 2, and we said that this right here is going to be double the side, well, guess what the side length is? What is 2 times 2.5 radical 2? Just 5 radical 2. So to me, using the side times side formula or base times height, that would be the easier one to do rather than using our 1/2 apothem times perimeter. Whenever you're using the square, I would just do it this way. So I'm going to do area is 5 radical 2 times 5 radical 2. So you had a unit of multiplying radicals. This should be pretty easy. 5 times 5 is 25. Radical 2 times radical 2 is just 2. So the area of this is actually 50 square units. Okay. Alrighty. Let's go into another one. This is a regular triangle. I know the apothem, but I have none of the sides. So let me show you how to get to that pretty easily. Let me tell you the number one thing that is incorrect. Everybody thinks, well, if this is 8, well, this is 8 over here. That's incorrect, guys, okay? So don't think the apothem is half of that height, okay? So let's get rid of this. This is incorrect. Okay, so the best thing that you always want to do, guys, is kind of like what we had on the square, is draw in your radius, okay? Why? Because you have a right triangle, and you know the angle measures of every regular polygon. You know how to solve for them. In this case, these are all 60, and you should know that this is 30. So now we're dealing with a 30, 60, 90 triangle. So once we find the length of this side, I get to use my formula 1/2 apothem times perimeter, okay? So I need to figure out this leg down here. Well, I know the short leg, and again, I have a pretty good memory of my special rights. So if the short leg is 8, the long leg is going to be 8 radical 3. Well, guess what? This is all symmetrical, so it's going to be 8 radical 3 over here. So what is the whole entire side length? 8 radical 3 plus 8 radical 3, or 2 times 8 radical 3 is a better way to think of it, is just 16 radical 3. So all of the side lengths are 16 radical 3. Okay, so let's do our formula. 1/2 apothem times perimeter. It's going to be 1/2. The apothem is 8. And then the perimeter is 3 times 16 radical 3. So what is 3 times 16? My brain is dead right now, so I'm going to get my calculator. 16 times 3 is 48. So 48 radical 3. So I'm going to plug that into my perimeter. So see how I'm plugging in for each term. All right, I know half of 8 is 4, and then I'm going to do 4 times 48 radical 3. Again, I've been preaching this to my students in class. A lot of people want to distribute that 1/2. This is not the time to distribute this number, okay? So don't mix up your algebra, okay? You only distribute a number when it's outside of parentheses and you've got 2 terms that are being added or subtracted. That's the only time you distribute, okay? All right, so 4 times 48, let's use the calculator again. 192. Oopsie. So 192, and I'm not going to multiply the radical 3, I'm going to leave it in radical form. So 192 radical 3 units squared. Some people are probably thinking, well, what if I want to put it in decimal form? Yes, you can put it in decimal form if you want to, so I'll tell you what that is. 192 times the square root of 3 equals about 332.554 square units. Okay, which one you ask is the better answer? The exact one. This one right here that's in radical form. Okay. Okay, let's try another one. What do we have here? We have a regular octagon. Again, I don't know the apothem, which I need. I know the side, so I actually can plug in something into my formula. The perimeter, which is, perimeter is 8 times 12, because there's 8 sides in an octagon. So 8 times 12, I believe is 96. Okay, so we're going to plug in 96 to perimeter. Now I just need to solve for the apothem. Okay, so what do you want to do? You want to draw in that radius. Okay, and there we go. So this one's a little bit tougher. Okay, it's not 30, 60, it's not 45. How do you figure it out? Well, you know how to figure out the measure of each one of these angles. Okay, it's 8 sides, so I'm going to multiply 6 times 180, which is the total number of degrees is 1080. And so each one, I'm going to divide it by 8, is 135 degrees. So 135, 135, and so on, okay? So let me also explain to you that every time a radius is drawn to the vertex, it's going to bisect. So if this is all 135, what you want to do is take 135 and divide it by 2. So this angle right here is which is what we need, is 67.5 degrees. Why do we need that? Because we need that to solve for the apothem. Okay. Okay, so here's the other thing. We're missing a side length. Okay, what is this side from here to here? What is the side from here to here? Well, if the whole thing is 12, you should know that this is always going to go directly to the center, okay, whenever it's perpendicular. So that means this is 6 and that's 6. So now I know the adjacent side to that 67.5, and I know the apothem. So let's use tangent. So tangent of 67.5 degrees equals opposite over adjacent. I know the A might be confusing because it stands for adjacent, but our little a is standing for apothem. Okay, so we're actually going to have to deal with a decimal. So we're going to multiply 10 times 67.5 tangent equals. So the apothem is about 14.485. 14.485. And so right here, our apothem is about 14.485. Well, I have the long number in my calculator. I'm actually going to leave it there, and I'm going to multiply it by 96, and then I'm going to take half of that. So I'm going to times that by 0.5 or divide by 2, whichever you prefer. So The actual area of this is 695.294. Okay, and this is units squared. All right, so you always want to focus, and I'll highlight this, you always want to focus on finding the right triangle to work with. So you can use trigonometry or a special right triangle. All right, let's try a couple more. A little bit different. This is a hexagon. Okay, so what is the measure of each angle in a hexagon? Okay, because we know the apothem, and it's always good to label these guys. So we know the apothem, but we don't know the side. Okay, so we're going to solve for that. So how many degrees in a hexagon? So that's 4 times 180, 720 degrees. Divided by 6 angles. Each one is 120 degrees. Okay, well, if each one's 120, remember these are equal, that means this is a 60-degree angle and this is 30. We have ourselves another 30, 60, 90. So not only does it exist in the triangle, it exists in the hexagon always. So if that's 30, this is the short leg, and if the hypotenuse is 6, look, it even follows the pattern. That's is 3 radical 3, so the short leg is actually 3, which makes this half over here 3. What is the whole length? 6. Okay, let's check this out. Look, every side length here on the hexagon is always going to be the same as every radius. So see this radius right here? That is 6, because this is 6, and we just figured it out by using the measures. Okay, every radius is going to be 6. So what do we call all these triangles right here? These are all regular triangles. So in a hexagon, it is made up of 1, 2, 3, 4, 5, 6 regular triangles. Okay, so that's something to think about. This right here that I'm about to shade, that is a regular triangle. Okay, and all 3 side lengths are 6. Okay, so now I know the apothem, I know the side length. Now I can use my formula to find the area. 1/2 apothem times perimeter. Well, we knew the apothem, it's 3 radical 3, and the perimeter is 6 times 6, which is 36. I'm going to leave my answer in exact form, so I'm going to leave it in radical form. So here's what you multiply. You're multiplying 1/2 times 3 times 36, and you're going to leave it in the form of radical 3. So what is 1/2 times 3 times 36? That would be a total of 54. 54 radical 3 square units. Again, if you want to put it in decimal, you can type that into the calculator. All right, let's try this one over here. We've got a pentagon over here. They gave us, this one is nice and simple. They gave us the apothem and they gave us the side lengths. So I can easily find the perimeter in this case over here. So let me get a different color. So I've got 1/2 apothem times perimeter. The apothem is 11, and the perimeter is, I don't know, what is 5 times 16? 80. All right, so it's just a simple multiplication in your calculator. 0.5 times 11 times 80. 440. So this area is 440 square units. Nice whole number. All right, last 2, squares, okay? Again, you should be able to do this one really quick. Why? They gave us the apothem, but don't use this formula, even though you might want to. Remember, the apothem is always half the side length. So what is the entire side length? 1.2. So if all of the sides are 1.2, might as well just do base times height, or side times side. Let's get the perimeter real quick. 1.2 times 4 is 4.8 units. They didn't give us any. And so 1.2 squared, or 1.2 times 1.2, is 1.44. That is your squared units, because we're doing area. All right, let's take a look at this last one. What did they give us? They gave us this radius, okay? Remember, you always want to relate it to a right triangle, okay? Because this is part of the formula, the apothem. So if we can get this apothem, we can get the whole side. Remember, the apothem is the same as the whole entire side length, or double. Okay, so we just need to double this, and then we have the side length. Okay, remember, this is a 45-45 special right triangle. The hypotenuse is in the form of square root of 2, which is what we want. And so guess what? That makes life easy, because if this is 6 radical 2, guess what each leg is? 6. There's 6. This is 12. So the area is 144 square units. All right, so we did a lot of examples with regular polygons. That should help you with the homework.